Now let us start with a new topic called as Mapreduce. So whenever we were talking with respect to big data analytics, then Hadoop distributed file system and the Mapreduce are the two major components. So we have already seen what is HDFS, that is Hadoop file system, and Hadoop distributed file system. And now today we are going to learn something about the second component called as Mapreduce. So what is Mapreduce exactly? So Mapreduce is nothing but a programming model for data processing. So the model is very simple, yet it is simple to express some useful programs in which Hadoop can run Mapreduce programs written in various languages. We'll see them one by one. It is nothing but a programming model where we need it for data processing. So as an example for working with the data processing, let us consider one weather data set which will be very good example to fetch the data, because the weather sensors collect the data every hour at many locations across the globe and gather a large volume of log data, and this becomes a very good example for our analysis with the Mapreduce. And not only that, whenever we are making use of the sensors, sensors makes use of the messages, and the messages are stringed into a file which are completely semi-structured, so they don't have any structured information. So we have a semi-structured information. So how to work with this semi-structured information, we'll be saying with respect to Mapreduce functions. Now let us see what is the data format present inside the weather data set. So the data what we will be using is from the National Climatic Data Center, that is taken from ncdc.noaa.gov, which is the data stored in the form of ASCII format, in which each line is a record. So the format supports a rich set of meteorological elements, many of them which are optional or with variable data lengths, and for simplicity we will just see only temperature. So here the optional elements or meteorological elements, what I mean to say is, whenever we say a weather, then there is a wind speed, then there is a humidity, then there is a quality index of air quality index, and many other things present inside that climate center. So for simplicity, we shall just consider a temperature which is always present, and they are always of fixed width. So this is an example of format of a National Climate Data Center record. So here we have identifier USF. The number whatever we are seeing here is the identifier for USAF weather station identifier. This is one identifier which takes around 5 to 6 letters. Then this is our long variable in the form of date and time, observation time. Then it is taking the latitude and the longitude of the particular position. Then we are making use of elevation in meters. Then we are considering wind direction, then the quality code of the particular wind direction of wind. Then we are having sky ceiling height in meters, then quality code of that sky ceiling, visibility distance, quality of that visibility distance, then air temperature, then quality code of that air, dew point temperature, quality code of that particular dew point, then atmospheric pressure. So this is what the data looks like. So it looks a little bit clumsy whenever we are seeing this type of data, but let us see how exactly this is going to be used when we are working with the Mapreduce. So we are just concentrating upon the temperature in this particular program. So most of the files present inside this are zipped into the files depending upon what date they are being taken, what month they are being taken, and what year they have been taken. So here for example we can see here there is a date 01, which is a month, then the 01 is the date, and 10, 14, 15, 16 these are the dates, and these are taken in the form of a 1990, which is nothing but a year. So this is nothing but the entries, the first entries of 1990 year in the form of gzipped file. So how to work with this using the Unix tools. So in Unix, most of the times we make use of the awk file or the shell file, and this is the awk file. So we are making use of this is a bash function. We are opening the editor, and here for year in all /star. So we have seen the globbing function there. Star means the globbing function. Then do echo -ne base name year.gz. So the base name will be the year of base name on the file name, then the year. So year in the form of command whatever we will be giving, that will be taken in the form of year, and gz is our zip file name. And we are making use of this -c command for fetching the year. Then using temperature equals to substring 0, $0 is the argument 88,5. So why this 88,5 we will be seeing in our next slides. Plus 0, then we are fetching the substring 0 that is the first argument, then 93,1. So what exactly this does? So here we have one temperature, and here we have something called as Q. So this is used for fetching the temperature, and this is used for fetching the, let us say, date or whatever it is. So if temperature is not equal to 9999 and Q is the using the tilde operator 0149, and temperature is greater than max equals to temp, and end print max. So we are just trying to get the this one maximum temperature in a year. So here temperature equals to substring, we are getting to get the temperature from the each one of the line. So here we have a complete lines. So in that lines we are going to a particular line by making use of temperature equals to substring 0,88,55. So 0,88,55. So all this information will be in the form of one message, and the number whatever we are giving here, that is 88,5, is the place in that particular message of that particular string. Then 93 and (1) is used for fetching the temperature, that is year value in that particular year. Then we are just going to search the make use of some logic here for checking whether the temperature is equivalent or not equal to 999, because it will be invalid if I make use of more than 10,000 as the temperature. Then Q is not equal to 0149, which is a year, and temperature is greater than max, so max equals to temperature. So we are just using this logic here, and we are printing the max. So the script loops, whatever we have used, the same explanation has been given in this particular slide. So when we run this program, then max temperature.sh, which is a shell file. So 1901 we got 317 in the form of Fahrenheit. Then 1902 244, 1903 289, 256 and 283 as a beginning of a run. So it is not the complete output, it is just the partial output. So to speed up the processing, what we do is we run parts of the program in parallel. In theory, this is straightforward. We could process the different years in different processes using all the available hardware threads on a machine. There are a few problems whenever we are trying to work with the parallel processing. Then the thing is, we need to divide the work into equal size pieces, which is not easy always. And we are making use of the combining the results after independent processing. Then most of the times we have the processing capacity is limited for a single machine. So we are analyzing the data with the Hadoop, map and reduce. So there are some different functions called as map and reduce. So the map phase and the reduce phase. So the phase, each phase has a key value pairs as input and output, the types of which may be chosen from the program. The programmer can choose any of its type. So the programmer also specifies two functions, that is map function and the reduce function. So let us see the data, how exactly this is. So here is the data what we are trying to fetch it. So here we have many numbers, and the same thing here also we are seeing. So here the bold things whatever we are seeing are the years, or we can say we can fetch this by making use of a string function by giving the place of that particular string character. So from this particular string character we can fetch the year, and here we are trying to fetch the temperature. So in the full file we are just trying to make the key value paste. So here 1950 is a key and value for that is 0. Similarly for 1950 we had 22 minus 11, 111 and 78. So for 1949, if it is the key and the values for this 1949 are 111 and 78, and for 1950 we have 0, 22 and minus 11 as per the previous records. So whenever we want to reduce, all the reduce function has to do now is to iterate through the list and pick up the maximum reading. So whenever we got this list, then it is very easy for us to retrieve the list, and the output of this will be here in this case we have 111 which is the maximum, and here we have 22 which is the maximum, which can be fetched very easily. So how exactly this MapReduce logical data flow looks like. So here we have the data in the form of input, then we make use of the map function. So after making use of the map function, in the full data whatever we have, by making use of the string places or character places inside the string, we get the key value pairs, and after getting the key value pairs we reduce it to the combination something like a, which looks like a key along with the list of values, and we are getting the maximum value of the as the output. So for this we have some Java functions. So the Java function Java MapReduce, where we are using the mapper function, and here we can see these are all the import functions which is taken from the Hadoop MapReduce function, MapReduce class and IO class, where we have report, output, collector, mapper, MapReduce space, text, long writable, int writable. These are nothing but the classes which will be helpful when we are trying to work with the program. So let's see how the mapper looks like. So we are using a complete class called as max temperature mapper, extends MapReduce space, which is the superclass of this, and it implements the interface called as mapper, which takes a generic data type of long writable text, then int writable. So in this mapper function we can say that we are making use of some integer variable called as missing, and we are giving it as there is one less than that is 10,000, because we start from 0. Then we are making use of a map function called as map, which is taken from the interface called as mapper. Then we are making use of the parameters in the form of key, then the text value, then the output collector, which is in the form of generic, which is having text and int writable, then the output reporter, and so on. So these are the arguments passed through the map function. So when we are making use of this map function, we are using a line equals to value dot to string, so we are converting it to string. Then we are using the string equals to year, then we are getting the substring. So the substring from 15 to 19. So the places where the year is mentioned is in the substring 15 comma 19. So similarly we are getting the air temperature, and the air temperature here sometimes some people may use a plus and minus for the temperature. So we are using, some people use a plus for that. So to avoid that plus we use if char at 87, so we are just ignoring this, and we are making use of air temperature equals to 88 comma 92, which is the place of that. Then we are making use of air quality in substring, then we are getting 92 comma 93, and the temperature not equals to missing means it is not above 999 and matches 0 to this range. Then we are collecting the year and everything, and we are writing it into a writable integer thing. So I will see the next reduce function in our next session.